In this topic of components of an image processing system, we are going to see about some of the basic blocks involved in it. The first comes the image sensor. Whatever the problem domain we are going to capture, that will be captured by the image sensors. The first is a physical device that is sensitive to the energy radiated by the object we wish to image. Second, called the digitizer, is a device for converting the output of the physical sensing device into digital form. So these outputs will be stored as to the digital form, and this will be given to the special processing image processing hardware. Next, the specialized image processing hardware. In this, we have a hardware that performs major primitive operations like arithmetic logic unit, which is able to do the arithmetic and logic operations in parallel on the entire images. So how ALU is used in averaging images as quickly as they are digitized for the purpose of noise reduction. This type of hardware sometimes called a front-end subsystem, and it is most distribution characteristic in speed. In other words, we can say that this unit performs functions that require fast data throughputs, examples digitizing, averaging video images at 30 frames per second. Then comes the basic centralized part computer. The computer is an image processing system. It can range from a PC to supercomputer. In dedicated applications, sometimes custom computers are used to achieve a required level of performance, but our interest here is on general purpose image processing systems. In these systems, almost any well equipped PC type machine is suitable for offline image processing tasks. The next block is the image processing software, which is used for specialized modules that perform specific tasks. A well-designed package also includes the capability for the user to write code that as a minimum utilizes the specialized modules. More sophisticated software packages allow the integration of those modules and general purpose software commands from at least one computer language. Then the mass storage block, which is a must in image processing applications. An image of size pixels in which intensity of each pixel is an 8-bit quantity requires 1 megabyte of storage space if the image is not compressed. Digital storage for image processing applications falls into three principal categories. First one, frame buffer, online storage for relatively fast recall. Then comes archival storage, characterized by infrequent access. Then comes the image displays block. It is like just a TV monitor or laptop monitor or any system we have used and to view the output. Monitors are driven by the outputs of the image and graphics display cards that are an integral part of the computer system. Rarely we say that the requirements for image display applications cannot be met by the display cards available. In some cases, it is necessary to have stereo displays, and these are implemented in the form of a headgear containing two small displays embedded in goggles owned by the user. Then comes the hard copy. Hard copy devices for recording images include laser printer, film cameras, heat sensitive devices, inkjet unit, digital unit such as optical and CD-ROM discs. Film that provides the highest possible resolution, but paper is the obvious medium of choice for written material. For presentations, images are displayed on film transparencies or in the digital medium of image projection equipment is used. The latter approach is gaining acceptance as the standard for image presentations. Then comes the network. Networking is almost a default function in any computer system in use today. Because of the large amount of data inherent in image processing applications, key consideration in image transmission is bandwidth. In dedicated networks, this typically is not a problem, but communication with remote sites via the internet are not always as efficient. This situation is improving quickly as a result of optical fiber and other broadband technologies. Thank you.